in college algebra, we started a new chapter, Systems of Equations. Typically, we have two equations with two variables, but we may look at more complex situations. Let's start out nice and basic. Let's check if a coordinate is a solution to a system. So we can check by plugging in to test if it is a solution. Should give us a true statement. If it gives us something that doesn't make sense, like for example, if it says 3 equals 2, that obviously doesn't make sense, and we would say no solution. So let's plug in 4, -1 into the first equation. And we end up with 4 minus 2, which does equal 2. Whoops. There we go. Let's plug in 4, -1 into the second equation. We have 4 minus 2 times -1 equals 6. And we get 4 plus 2, which is 6. So since we get two true statements, yes, it is a solution. All right, another way this is presented is it doesn't give you the answer, and we got to find the answer. We're going to use methods like substitution and elimination, graphing. We'll look at a whole different method of solving things in the next chapter. And these two methods, substitution and elimination, are used. It honestly is up to the person that's working the problem which method they pick, but for me the way it's presented, the way it's typed, dictates how I solve it. So look at number 2, look at number 3, and number 2, it's already set equal to y right here, so I know that y is represented by that. I can plug that into that y, and then I'll only have x's, and I can solve for x. So that's what this means up here. Solve for one variable. That's already done. Y equals. Then you plug in whatever that equals into the other equation. So let's rewrite this. This is 4x minus 3. Use parentheses where we substitute. I'm putting -x minus 1 in place of that y, and then equals 24. Distribute that -3. Let's get rid of the 3. And x is 3. We're halfway done. Make sure you get y. So y equals negative, plug in a 3 minus 1. So y equals -4. Feel free to write it as a coordinate, kind of organizes your answer. Or you can just write what x equals and y equals. For the elimination method, we need one of the variables to cancel out when I combine the equations. So if I combine them right now, I get 12x and -6y. Canceling out doesn't happen. Something else that leads me to doing elimination is the variables need to be stacked, like terms. Look at number 2 and look at number 3. See how in number 2 the y's are not lined up? Let me change colors. Looking at number 2, the y's are like crossways. The x's are on different sides of the equal sign. That doesn't work. So on number 2, they're all lined up, ready to go. So maybe make a note to yourself, like terms need to be lined up, stacked over each other. However you most make sense of it. So you randomly pick one of the letters to cancel out. Let's pick X. You could have picked Y. Doesn't matter. So if I was to make this 3x become a negative 9x, when I combine the two, they would cancel out. So let's do that. Let's multiply that top equation by negative 3, and it's going to make that 3x become a negative 9x. I get negative 9x. I get negative 6y. And 3 times 48, that's 120, so 144. So negative 144. Let's just copy down this equation. And combine the equations. The x's cancel out, that was the goal. And we end up with negative 14y equals negative 168. Hopefully 168 is divisible by 14. And we get 12. I need to figure out what x is, so let's plug 12 in for y. 3x plus 2 times 12 equals 48. Plug it into either equation. And 3x equals 24. X is 8. So our final answer is 8, 12. All right, let's try one last one. It's pretty horrible. It's a rough one. I think we can do it. We get bad numbers on this one. All right, the nice thing is the Inspire can handle a lot of this. So first off, the equations are not stacked above each other. Notice the x's are not above each other. The y's are not above each other. So I'm going to rearrange. And I'm going to write the first equation like this. And I'm going to write the second equation like this. Make sure when you move a term across that equal sign, you flip its sign. You can't just pick it up and move it. Let's make the x's cancel out. So starting out, it doesn't look too bad. Let's pick a common multiple. Let's make them 6 and negative 6. If I multiply this by negative 3 and this by positive 2, I'll get some 6's and I can cancel things out. So we get, go back to green, we get negative 6x plus 21y equals 51. That second equation becomes 6x plus 10y equals 34. Still not bad at all. We combine the two equations. The x's cancel out like we planned, but I'm going to get an ugly result. When I divide by 31, I get just that fraction. So, and you can try and type it in, it does not divide or reduce. I need to plug that into one of the originals and get x, and this is where it really gets ugly. So let's plug into the first one, doesn't matter which, the original equation. I'm going to put 85 over 31 in place of the y and see what we can do here. When we multiply 7 times 85, we get a horrible number. On the Inspire, it'll take care of this. So if you were to type that top line, 7 times 85 divided by 31, it'll give you that fraction. If you were to type minus 17, it'll handle that as well. There's no need to mess with getting a common denominator, a 31. That's no fun at all. But if you want to, multiply by 31 and you get 527 over 31. That ends up being 2x equals 68 over 31. And then you divide both sides by 2, and you finally end up with this number here. So final answer is this horrible thing. It's good fraction practice, though. I'll try not to give you one that ugly on a test, but I will see y'all later. Bye.